Okay, example 2. Evaluate this thing. All right, so we have the cube root of x cubed plus 3x squared minus 2x plus 1 on the bottom. We have 6x squared plus 12x minus 4 on top. Rational functions, as a rule, typically the u is going to be living on the bottom because du multiplies, multiplication goes on top. So probably, if I'm looking at this, I'm looking at this as a power function. A radical is a power function in disguise, right? Cube root's a third power. And if I look at this as a power function, so I'm focusing, that's weird. Did that just go like yellow when I picked yellow? That was kind of flickering too. Am I imagining this, or let's see.
That's weird.
Good video here.
Alright.
Wow.
Is it like on the computer screen? Oh. There you go.
Alright.
Alright.
So, this is a power function, so I'm focusing on this. Okay, I don't care about the top. I care about my function, right? So it's a power function. There's where the power function lives, right there on the bottom. And I can see that the argument of that function is x cubed plus 3x squared minus 2x plus 1. So, if I say over here u is equal to x cubed plus 3x squared minus 2x plus 1. And once I've established what u is, I want to find the differential, du. Du here is going to be 3x squared plus 6x minus 2, each of those with a dx on it, right? So I can put a big parentheses around it, dx. There's only one dx in the problem, so I only want one dx in my differential. So typically what's going to happen is your argument is going to be all about x. So when you differentiate all this stuff, just put it in parentheses with a dx to the side. And what hopefully all of you are thinking right now is that doesn't look the same as that. Are we all thinking that? Okay, the dx works, right? There's dx, that's good. So we'll circle around that. We're happy about that. Okay. Now, the issue is the numbers. The numbers don't match. The letters match. X squared, x, and constant, right? The constant's not the right constant. But notice each of the numbers. 3 is half as big as it's supposed to be, 6 is half as big as it's supposed to be, and negative 2 is half as big as it's supposed to be, right? So take a look at this top expression here. This, if I rewrite this, would everybody agree if I factor the 2 out of that, I'm going to get 2 times 3x squared plus 6x minus 2. The dx we can put on top all over the cube root of x cubed plus 3x squared minus 2x plus 1. That problem's equivalent to what we have, right? This is the issue you run into sometimes. Sometimes the differential, like in example 1, is exactly what we need it to be. And again, those are our ones that make us feel happy about calculus and makes us happy that we made this wonderful decision to enter a calculus classroom and become smarter, right? Problems like this make us a little less happy because it didn't match up. But if we can factor a constant out, it has to be a constant. If I factor an x out, we're no good. We'll have to do some other stuff that's a little bit more challenging. I think that's day 3 of this lesson. But if we have a constant issues are easy. So if we take a look and compare what we have, would everybody agree that this guy down here is u? Right, that's u. All right, and this guy here is du. The only thing that's not accounted for is that 2. And when we first learned about integrals, I told you that if you have a constant in the integral, you can pull the constant out of the integral. That's legal. Right? Constant multiples don't do anything in calculus. They just come along for the ride. So just pull it out of the problem, stick it out there. So at this point, if I rewrite this problem, notice it looks like this. 2 times the integral of, we have du on top, we have the cube root of u on the bottom. And I've transformed it from this x integral into this u integral, where everything's about u, nothing about x. That's the key. We want to get there every time. Now, as far as integrating this, I don't like the structure, so I would change the structure to u to the negative 1/3 power du. Negative powers are better than radicals and fractions. And once I get a workable structure, now I'm going to anti-differentiate. So again, the 2 is just coming along. It's part of the answer, but it's just not really affecting the answer at this point. U to the negative 1/3 antiderivative is u to the positive 2/3 times 3/2 plus c. If I distribute the 2 through there, I'm going to get 3 u to the 2/3. Now this bothers people sometimes. I'm going to put plus c. Most people think that should be 2c. It could be 2c if you felt like it. What does c equal? Some constant, right? That equals some constant, that still equals some constant. It doesn't matter what it's called. I could have put the brackets stopping here if you want. It doesn't matter. Just know that when you have an indefinite integral, you're going to get a plus c on your answer. Alright, so 3u to the 2/3 plus c, and now I've got my answer. Now I'm going to put u back into the problem. So I'm going to get 3 times x cubed plus 3x squared minus 2x plus 1 to the 2/3 plus c. The nice thing about indefinite integrals, they're very easy to check. If you're not sure you're right, all you have to do to check it is take the derivative. Take the derivative of this, see that you get that. That's what you should get. So if we try it out real quick, just go, oops, like that. There. Extend the page a little bit here. Chain rule, right? Power times front makes 2. The argument x cubed plus 3x squared minus 2x plus 1 to the negative 1/3 times derivative of the inside, which is 3x squared plus 6x minus 2. If I then rewrite the derivative of c, of course, is 0. This is on top, that's on bottom. So 2 times all this stuff makes 6x squared plus 12x minus 4. And on the bottom we have the cube root of x cubed plus 3x squared minus 2x plus 1. Same as the original problem. So therefore we did it right. Okay? So again, very easy to check these problems. If you do the chain rule on the answer, you should get the original problem. You don't have to do that, but if you're unsure of yourself, you're not sure it worked right, you're not sure you did it correctly, that's how you check to make sure you did it correctly. One thing I want to bring to your attention real quick before you do the homework tonight, in case this happens. This might happen. Suppose we do this. I'll do an easy one. Let's go x squared plus 1 to the 8th power, and let's just say that this is x. Alright, let's just say that we have that. So what type of function is it? Power, what's the argument? X squared plus 1. U equals x squared plus 1. If you're having trouble finding the argument, read the problem like this. Something to the 8th power, whatever something is the argument. Right? So if you're having trouble identifying the argument, if you use the word something to represent the problem, x times something to the 8th power, whatever something is the argument. U is equal to x squared plus 1, du is equal to 2x. This happens sometimes too. Oh, dx. Obviously x is not the same as 2x. Alright? But again, x is the same as x, dx is the same as dx. The issue is a numerical problem. It's not a letter problem, it's a number problem. Number problems are easily fixed. The last number problem, we just had to extract a number out, right? Because there was too much there. This one doesn't have enough. That happens sometimes too. The way you handle not enough is this. Very, very simple. I'm going to put what I need in there. Isn't that simple? Okay. Am I allowed to do that mathematically? I need something, so just put it in there? If you knew that now, and you could have known that all the way through algebra, you'd be mad at me, right? So obviously that can't be true, because I would have told you much sooner than this. Oh, if you need something, just put it in there. I needed 2 in there, so I put it in there. To account for that, I'm going to put a 1/2 out here. What does 1/2 times 2 equal? 1, right? So I'm multiplying the whole thing by 1. I'm putting part of the 1 inside, part of the 1 outside. But I'm multiplying by 1. That gets me exactly what I need for my dx, right? So du is that. So there's 2x dx is du. That's u to the 8th power. To put the 2 there, I had to put the 1/2 there. So the problem becomes then 1/2 outside integral of u to the 8th du inside. And now I can work it out. So again, if it's a matter of factoring something out and just pulling that factor out, that's fine. If there's a matter of something actually missing, some number actually missing, put the number you need there, just put its reciprocal out there to account for it. And then you created it, but you just have this extra added feature to the problem now. That 1/2 is part of the problem. U to the 9th over 9 is the antiderivative plus c. So we get u to the 9th over 18 plus c, which is x squared plus 1 to the 9th over 18 plus the 9th plus c. 9 times 1/18 is 1/2. X squared plus 1 to the 8th times 2x. That 2 cancels that 2 in with x times x squared plus 1 to the 8th. Right? So again, if you need it, put it in, just put its reciprocal out to account for it, then you're ready to go. It'll either be exactly what you need, a factor gets pulled out, or you need to invent a number and its reciprocal outside. Those are the types of issues you're going to run into in the next one.